Now what you're going to see on this is a shorter method. Keep an eye on me to make sure I copy these things correctly, because I don't have my glasses on here. We have 1 over what? Okay. And this one is a plus, isn't it? Now, one of the things I told the other class you might want to do in this method, rewrite the problem, or if you can do it as it's written, it's fine. But what I'm going to do is rewrite it with a little more room between the fractions, and you'll see why here in a second. What's the second fraction? 3 over 4cd cubed. Okay. Now here's the cool thing that they liked, and it works really well. First of all, you factor if you can. 6 can be factored, so you should do that. 4 can be factored. Now when I say factored, you should go all the way down to prime numbers where they can't be factored anymore. Now here's all you do on these. This is a short way of doing this. We're not going to write a new set of fractions yet. We're just going to look at everything that's there, and whatever's missing in one, we're going to put in the other. How many 2's do I have here? So aren't I missing a 2? So I've got it. Now I need to do that to this. So whatever I do to this, I have to do to the top. Please do this with me. You shouldn't just sit and watch. You should be writing this down and doing it with me. Now let's go ahead and write. I'm going to do this just so we can see everything together. So you can see it all together. Now see, what we're trying to do is we're making the denominators alike. We've taken care of the, don't we have two 2's in each now? All right. What's another factor of numbers up there? I have a 3 in this one, but do I have one in that one? So I need to multiply this one by 3 and this one by 3. See, top and bottom, numerator, denominator. Now let's do the letters. What's the highest? We've got a c squared, right? So what are we going to have to do over here so we have a c squared? Are we going to have to multiply by c, right? And that's what we'll have to do to the top. Whatever you do to the bottom, you got to do to the top. How many see what I'm doing? Are you following this? All right, now we need to look at the d's, don't we? We have a d to the third, don't we, over in the second fraction? Well, we know how to make this a d to the third. How do we do that? And whatever you do to the bottom, do to the top. Now, if I multiply all of this together, I mean, I actually can see now that I've got, what's 2 times 2? Times 3? 12. I have my new denominator. Now you're going to write your new denominator. Only one fraction. This is going to be my answer. Now, don't I have a c squared in both now? C squared here, c squared. And what's the d in both? This is a d cubed, and we got a d cubed here. And there's your least common denominator. Now, please watch. This is where people started making mistakes. Just work with one fraction at a time. 1 times 2 times d is what? D squared, excuse me. Isn't that just 2d squared? Yes? 1 times 2 times d squared. Now, I'm not multiplying this times the other one. Some of you multiplied. I don't know why. What's between them? Why would you multiply? So this would be a plus. What's 3 times 3 times c? I'm done. That's your answer. I can't add these, can I? They are not like terms, are they? How many got number 1 right? Correct. Okay. So you got 2d squared plus 9c over 12c squared d cubed. All right, let's do number 2. Number 2, we have 4 over a minus 3 plus, and what's in the other one? Thank you. Now do this right away. What do we have up there in both denominators? Binomials. Do this right away. Do it right away. Anytime you see a binomial, put parentheses around it. Now, neither one of those can be factored, can they? No. So let's do my new denominator. What's missing in this one? We got an a minus 3, but aren't we missing? So we're going to multiply top and bottom in the first one by a minus 5. What's missing in the second one? Now, don't we have denominators alike? Right? Don't we have denominators alike? And whenever you multiply the bottom by, you multiply by the top. So what's my new common denominator? So write that down. A minus 3, a minus 5 is the new denominator. Now you're going to simplify in each and combine and put them on in the new numerator. Don't we have to distribute here? 4 times a is 4 times a negative 5. Now what's between the two fractions? Yes, do not multiply. I can't believe how many people took this top times this top. Really disoriented, I guess, about what we were doing. Now we just distribute the 9, so we got what? Plus 9a, because of the plus here, minus 27. Now if you stop there, I'd take a point off, because can't we combine like terms on top? So what's 4a plus 9a? So all of this is going to be written over your least common denominator. You already know what it is. So we took care of these. What's negative 20 and a negative 27? All over our denominator. Do not multiply it together. Do not multiply it together. I've said that a bunch of times. We do not want to multiply them together. And the reason why is because once you get your final answer, sometimes you can simplify. And then you'd have to factor it again. So you always leave them in factored form. How many got this one right? Okay. Is this helping anybody? Do you like this method better? It's shorter, isn't it? More concise. Let's do number 3. Now this one has a minus in it. Let's see, we got 2 over a plus 2 minus what? 3 over 2a. I'll make this minus a little bit farther over here. Now, what did I tell you to do the binomials? Put a parentheses around it. Now, do you understand? This is a binomial. This is a monomial. And neither one can be factored. We could make this time sign here, but we don't need to. So isn't the first one just missing 2a? Do you see that? So I've got to multiply this by 2a on the top and the bottom. What's that one missing? A plus 2. Now, one thing you're supposed to do when you start every problem that I haven't done yet. When you have a minus, what did I tell you should do immediately? Now here's why. How many of you would just distribute that 3 and you'd have 3a plus 6, but you'd only put the minus on the what? You'd only put it on the 3a, wouldn't you? That's why you do this. If you make sure you change this to adding the opposite, guess what you'll end up distributing? The negative. See, that's what you forget to do. That's why I'm telling you on every subtraction problem, immediately change it to adding the opposite. Now, what's our common denominator? 2a, a plus 2. And let's simplify now. 2 times 2a is what? And what's between them? Plus. Distribute on the other one, what do we get? Negative 3a minus 6, right? Negative 3a minus 6. Now we can combine like terms. 4a and a negative 3a. And then we don't have anything to add to the 6, do we? And all of that is over your least common denominator. How many got that right? We had a few people, yes. Again, is this making more sense this way? Okay. Number 4. I'm expecting a lot of good grades tomorrow. In fact, what I'm going to do is I'm taking this exact test and just changing some numbers and letters. All of them are going to be worked with the same type of factoring, the same type of denominator. Does that make sense? Just like on that one, we had a monomial binomial. That's what you'll have on that same number tomorrow, just be a different one. Because I want you to be able to concentrate and focus, yes. No multiple choice. Not on these. All right. What am I ready for? 4? Okay, this has a trick in it that I taught you. So we have 3t. By the way, this was supposed to be a 3t if I told you to change it to x. It was on your homework this way. I just thought it was weird that it was that way, but it was. Now, we have a minus, don't we? And 5 over. All right. Now, this one, how many knew that the -1 technique was what you're going to have to use on this? Do you recognize you have an x minus 2, then 2 minus x? Now, if you do what I tell you to do in the order that I tell you to do it, you won't make a mistake here. What have I always told you to do first? Change this immediately. Don't start the problem until you do that. Now, this can be worked 2 ways, and I saw the correct answer in 2 different forms. Some people took a -1 out of this one to make it look like the second one. Some people took the -1 out of this one, the second fraction, to make it look like this one. That's what I would do, because isn't x minus 2 more of the normal look? Are you following me? So, let's do that over here. I can take a -1 out. Now, even though I've taken the -1 out and I got an x minus 2 in there, the denominators still aren't alike. Do you see a -1 times the first fraction's denominator? So they're still not alike. Now, just don't forget all your math here. Just look at the second fraction. What can I do? Well, but just, yes. But also, what is a negative over a negative? Isn't that a positive? So now this is gone, and now you do have like denominators. And it got rid of the minus, didn't it? The negative. You see how that worked together. Now, we know our least common denominator is x minus 2. We can't do anything to the top, so it's just 3t plus 5. Now, some of you, again, had this in a different form because you took a negative out of the first one. That'll still be correct if you did it right. Okay, we ready to go on? Let's do number, is it 5? Yeah. Now, this one had 3 fractions. Some of you panicked just because you're not used to seeing that. Now, we got a minus 2a over a plus 3. And then we have a plus. Now, what is this right here? What's it called? Remember, if it's a perfect square, you do this. In fact, here it is, isn't it? Aren't these first 2 denominators that factorization? Now, as soon as you factor that, I like to mark it out because we're not using that part. We've changed it to that, changed its form. Now, let's just do what we've been doing. What did I tell you to do to these? What did I tell you to do to every binomial? Now, what was the next thing I said we need to do before we start the problem? Change your subtraction. This is very important here, too, because you're going to end up distributing that one. Now, does everybody see what's important to do at the first? Got all this down. Put your parentheses on your binomials. Change your subtraction to adding the opposite. Now, let's just multiply by what's missing. Don't we just have a plus 3 and a minus 3 to deal with? So what's missing in the first one? A plus 3, isn't it? That's all it's missing. So we multiply this by a plus 3 on the bottom, a plus 3 on the top. What's missing in the second fraction? So this one we've got to multiply by a minus 3 on the bottom, a minus 3 on top. Now this is nice. Anything missing here? I mean, look at your three denominators. Wasn't that our goal? Aren't they all three alike now? Now we can add and subtract or whatever. But let's write our denominator down here. And we're going to write our, after we do all this stuff, we'll put it together here and then we'll simplify. So let's do the first denominator. Distribute the 2, what do we get? 2a plus 6. Yes? Now what's between the two fractions? Did I leave an a off? Nobody told me. Why didn't you tell me? I told you I don't have my glasses on. All right, let me put a 2a in here. I'm glad we caught that before we got too far. So this is also a 2a. All right, good job. This will be a 2a squared, right? But this will be a 6a now, won't it? Yes? If I take 2a times 3, that's a 6a. Now what's between the two fractions? We got a plus, so now we put plus. Now distribute the negative 2a. That's going to be negative 2a squared. What's that going to be? Plus 6a. Right? Now we don't have to do anything to the second one or the last one except add it, right? Doesn't this say plus 36? Now we combine like terms and put it over our least common denominator. Something cancels here. Aren't these gone? What's 6a plus 6a? Somebody canceled those. I don't know why you canceled them. They're not opposite. So that would be 12a, wouldn't it? So we have 12a. And all that's left is a 36. All over. Now something that was disturbing to me yesterday, and I need to point this out, I pointed out in my other class. I had people do all this work right here. They made a new denominator on everything, and guess what they started doing? They started canceling. Right after they multiplied by it, or put it on there, they canceled it. Why would you start canceling? What happens if you cancel here? Does this denominator look like this denominator anymore? You just made them look alike and then you're changing them again. We're not canceling here. We're not doing any canceling. Not while we're adding and subtracting. But here's the thing you need to look at on this. I'm going to be real happy because we've had trouble with this doing this. If you got to here, I'm going to give you full credit. But it really, this now can be simplified. What can come out of the top? How about 12? What happens when I take a 12 out of this? Don't I get a plus 3? So see, this could be reduced. This could be simplified. This is when you simplify. After you have your final answer, then I could cancel the a plus 3's and leave, my final answer would be 12 over a minus 3. I had one person do this in all 3 classes. I think it was last period. They simplified it. Now, normally you should always do this, but I'm just going to be happy if you just get the answer right now. But that's what you should do if you know how to simplify. Yes? No. Not right now. All I want you to do, because you know why I don't want you to right now? Because what am I doing here? And that's what people want to do, just start canceling everything. If they think they're going to cancel, oh my gosh, they go canceling crazy. So no, we're not simplifying. Well, I just want you to prove to me you know how to add and subtract rational expressions. We're going to deal with that later. All right, let's do number, what are we ready for? 6. Now on this one, this is another situation that's a little different. Now didn't we have a minus on this one? Okay. Now a lot of you didn't know what to do with this first denominator. Right here. You tried to factor it into two binomials. That's not a trinomial. You can't factor that into two binomials. What's the first factoring you always check for? Common term. What can come out of both of those in that denominator? No, we're not doing that. We're not doing two binomials. See? We're doing this. And there's nothing else you can do to that. All you can do is take out a 2. So I'm done with this. Now what else should I do before I go any further? Change the minus to what? Adding the opposite, yeah. Now this you know how to, this is where you do your factorization into two binomials. What are the factors of 12 that are going to give me the 4 in the middle? 2 and 6. And doesn't the 6 have to be negative for this to work? So we get a negative 4 in the middle. And here was a hint. Remember how I told you sometimes the problem is going to give you hints on what to factor, what you're going to see? Now let's make the denominators alike by what's missing. What's missing in this denominator that's over there? Well, that's what we do then. And that's what you do to the top, the numerator. Now there's only one little thing missing on the second denominator, the 2. So we have to take this times 2 and the top times 2. Now don't they look just alike? So that tells you your least common denominator is 2x minus 6, x plus 2. Now we distribute. 5 times x, 5x plus 10, plus negative 40. Now there's only one thing we can combine there. Well, two things, but they're both constants, aren't they? Just numbers. So that would be minus 30, wouldn't it? So your answer on this is 5x minus 30 over x minus 6, x plus 2. Now here's another one. Guess what? Now that I'm done, I've got my answer, I can reduce. Remember how if you add two fractions and it comes out to 4/8, you don't leave it that way, do you? You'd write 1/2. Well, that's my final answer, but what's it going to look like if I take a 5 out of the top? So I'm going to be able to cancel. Simplify. And here's what I'm going to do tomorrow. If that can happen, don't try to make it happen. But if it can, I'm going to give bonus points for people that recognize times you can simplify. But don't go all crazy on me with canceling. But now you see this, these cancel, and my final answer really would be 5 on top, 2 parentheses x plus 2. I had somebody do this in one of my classes. They did the whole thing. But if you'd have had 5x minus 30 over 2x minus 6, x plus 2, I'd give you credit, full credit. Because right now I just want to make sure you know how to add and subtract rational expressions. All right, number 7. What do we got? 4z over z minus 4. Is it a plus? And z plus 1. Now I want you to notice something. Okay, what earlier did I say you should do right away with binomials? Put parentheses around them right away. Every one of them. every one of them. Now, this one's easy. What's missing in the first one? Z plus 1, isn't it? Okay. So we got to multiply this one by Z plus 1 on top, or on bottom and top. What's missing on this one? Z minus 4. Darn. And now, our new denominator is, okay. Now we simplify each numerator and combine like terms when we can. This is the distributive property. So 4z times z, 4z times 1, 4z, isn't it? Now here's where I'm really disappointed. You FOIL that one, but how many see that that's this? Isn't it a difference of 2 squares factored? So what's it going to go back to? When you FOIL this, aren't you going to get this? Because it's a difference of 2 squares. It's just been factored. Now if you FOIL it, you're going to see you'll have a negative 4z and a positive 4z, and they cancel, don't they? Is everybody okay with what I did there? So what do we have here? So we got 4z squared plus 4z plus z squared minus 16. Now you need to add like terms. So what's 4z squared and 1z squared? Yeah, not 5z to the 4th. We're adding like terms, we're not multiplying. Do we have anything to add to the 4z? And we have a minus 16, don't we? That's all we can do, all over your denominator. How many got that right? Just checking. 2 people. Okay. Again, if you can't recognize this, FOIL it. You'll get the same thing. Distribute, FOIL, and you'll get the same answer on top. All right, let's do number 8. Okay, what do we have on top? 2x plus 1. And on the bottom, x minus 5 minus 4 over x squared minus 3x minus 10. Again, we got a binomial here, and we got a binomial here, don't we? This one can't be factored, the first denominator, but this one can be. What would this factor into? Very good. And then notice again, here's that x minus 5 over here. Now what should I do over there? Change this to adding the opposite. Now what's missing in the first denominator? X plus 2. The other one's okay now, isn't it? We don't have to do anything to it. They're alike. We're done. Now let's, again, what are we doing here? On the top of the first fraction, we're FOILing. So we have 2x times x. Let's write our denominator here. So 2x times x. And then don't we have, excuse me, 2x times 2 plus 4x, 1 times x plus 1x. I'm going to write the 1 just for so everybody can see what we're doing. And then 1 times 2. I just FOILed it. Now I didn't add like terms yet. We'll do that when we write our final answer. Now, do I have to do anything to this? So I have plus negative 4. Right? Now combine like terms. And then we have our answer over x minus 5, x plus 2. By the way, one of my averages in one of my classes was 17%, because I had a bunch of ones, you know. But my guess is tomorrow the average will go up to at least 70%, so that'll be a nice big jump. In here it'll go up too. How many feel like you're going to do 100% better? How many feel like you might be able to get 100? Yeah, let's have about 10 or 12 hundreds. That'd be good. Well, what's on top now? 2x squared plus 5x. Okay. And it's over your x minus 5, x plus 2. All right, we got one more and we're done here. How many got no? Yes.
When we take this free quiz, it's not going to be on this time week, is it?
Oh, yeah.
Oh, it is?
Oh, it's got to be, or this would kill you. That's why I'm getting it tomorrow, because I know people aren't, you know, skip day, and everybody thinks they're seniors. All right. But yes, this is going to take the place of your score. All right, one more, and in fact, this was one that a lot of people got right. We have 3 over y squared. Is it plus y minus 12? Right? Now, this one has a minus, doesn't it? Okay. And then over here, we have a 2. Thank you. Okay, we have 2 binomials, or trinomials, so now we can factor those into 2 binomials. What are the factors for this? There's only one pair that'll give you a 1 here, and the 4's got to be positive, doesn't it? To give us a positive 1. Is everybody okay with that? Over here, this one was pretty easy. And like I said, tomorrow I'm going to give you very similar problems. Now, before we do anything, I know I sound like a broken record, which most of you don't even know what a broken record sounds like. You're too young. Thank you. Change this to add the opposite, because you're going to need to distribute that negative. All right, what's missing in the first one? Denominators. Yeah, we have a y plus 2 over there that's not here. That's right. And over here, we're missing the y minus 3. Now we have denominators alike. Let's distribute. So now we have 3y plus 6, don't we? Is that right? And then what's between the fractions? Now, negative 2 times y is negative 2y. Negative 2 times negative 3. And again, are you understanding how important it is to make sure you get to distribute that negative? That's why we do the plus the opposite. All right, add like terms and we're done. 3y minus 2y. 6 plus 6 is... I had people cancel those 6's for some reason. All over your denominator, yes. Y plus 4, y minus 3, y plus 2. And please don't start canceling too early. It's finally sinking in, isn't it? Aren't you glad that I do this? Most teachers just go on, don't they? I probably ought to cut that off there. I'm going to have to do some editing.